the review for 2022 Fall AMC 12A. So I think one of the interesting problem was problem 22, which let C be a real number and let Z1 and Z2 be the two complex numbers satisfying the quadratic z squared minus cz plus 10 is equal to 0. Points z sub 1, z sub 2, 1 over z sub 1, and 1 over z sub 2 are the vertices of a convex quadrilateral Q in the complex plane. When the area of Q obtains maximum value, C is the closest to which of the following? So this problem is a optimization problem. So now the first thing we would try to start with is going to be try to write the solutions in complex form, right? A plus bi, in order to visualize the quadrilateral. So from there we can see that by quadratic formula, z is equal to the fraction of c plus or minus the square root of c squared minus 40, right? Over 2. And this is the formula of z. Sorry, it takes now it's coming. So z is equal to c plus or minus the square root of c squared minus 40 over 2. But now we can see that this one is not in complex form since we do not have a imaginary part. But when c squared is less than 40, then we're going to have an imaginary part. Well, if it is not but we can see that if this one is actually greater than, then this one would be something like the 2 points would be this and this will be pretty small. So we have, and this one can actually be written as c plus or minus 0.2 plus or minus I times square root of 40 minus c squared. So looking here, we can see that we only multiplied the inside square root power by -1, which square root of -1 is equal to I, since we're taking the principal root. So we can see that the two solutions are going to be written as in the form of c over 2 plus or minus I over 2 times square root of 40 minus c squared. And we can see that these two will actually line in the vertical line of x is equal to c over 2, because the only variant here is going to be the imaginary part, right? So now, what about 1 over z sub 1 and 1 over z sub 2? So we can actually try to find a general case of 1 over z sub 1, or 1 over z in general. So now 1 over z is equal to the fraction of 2 over c plus or minus I square root of 40 minus c squared, right? And now we're going to be multiplying the conjugate of the denominator in order to get something cancelled out. So now we're going to do 2 times c square root of I square root of 40 minus c squared. And now in the bottom, we're going to do differential squares, right? Because, it's just differential squares. We get c squared plus c squared minus 40, right? Sorry, I didn't close the parentheses in the top. And this one can actually just be simplified as what? I'm just going to simplify it here as c squared minus 20, and we can get rid of the 2 on the top side. We also don't need the closing parentheses on the top. So this is what we got, right? So C plus or minus I times square root of 40 minus C squared over C squared minus 20. Now this one is actually the typical ways of 1 over Z. So now we can actually see again that C are constants, right? So basically C is like a numerical value. So basically we can see that these lines are parallel because both of them are on a vertical line. So you can see here, and because of symmetry across y is equal, because of the symmetry, right? The symmetry across y equal to 0, then this one's actually going to be an isosceles trapezoid. So because this one's an isosceles trapezoid, then we can just use 1/2 times 1 times base 1 plus base 2 times height, right? We can just use the typical arrow formula for a trapezoid. Well, now we can try to see that if we're trying to multiply or trying to adding the two bases, then we're just adding 2 times the length of the imagery part, right? Because we can see that the real part actually does not even change at all. And what about the numerator part? No, not numerator part, but the real part. So real part is only going to be affecting the height of the trapezoid, not the basis of the trapezoid. So this we can just write as 1/2 times. Well, what is base 1? Let's say base 1 is the longer side, right? So base 1 can be visualized as 2 times square root of 40 minus C squared. Well, if you want to like try to figure out why is that, then try to actually visualize this by like making a picture of a horizontal oriented isosceles trapezoid, and you'll see that's why. Now, well, we're also adding the shorter base. The shorter base is going to be 1 over Z, right? And we can see that we're adding, subtracting, then this is essentially like two times the imagery part. So 2 times square root of 40 minus C squared plus, well, actually we don't even need 1/2 since we know that this is 2 times the imagery part. So therefore we can just add the imaginary part of both the complex numbers. Then we'll be getting the sum of the bases times 1/2. So square root of 40 minus C squared plus the fraction of square root of 40 minus C squared over C squared minus 20. So this is actually the base. Let me make the parentheses greater. That's okay. Now we want to multiply by height, but height is just C over 2 minus C over C squared minus 20. So C over 2 minus C squared minus 20, right? So now we just need to actually evaluate this and try to find the maximum part. I'm just going to make this equation bigger since it's easier to visualize. And I'm going to make the parentheses better in order to make it look better. Right, so Now we want to actually like now we actually want to like maximize this value. Let me see whether I did anything incorrect here. Wait, no, I think I made a calculation error here. Sorry about that, but here is just 20, the fraction of 20. Now here is just 20 and the bottom just 20 and the other part just c my c squared 20, right? So now this one actually simplifies us a lot. So actually it's over 10 because we'll like cancel out 8, 2. Which we can actually just take out all the constant here, right? Which this one just equal to 11 over 10 times what? Times 9 over 10, right? And then multiply by c times square root of 40 minus c squared. So basically, we just need to like maximize c times square root of 40 minus c squared, and we get our answer because, well, 11 over 10 and 9 over 10 are both constant, which we can just ignore, right? Now we can use calculus to do it, which would kind of be fun, but not necessarily. But now we know that this one must be positive, right? So therefore, we can just put c inside it. So this will just, let me just write it clearly. We want to maximize square root of c square root of 4 minus c squared, which is equal to 40c squared minus c squared. So basically, we can just maximize 40 times c squared minus d to the 4th power. Then this is actually just our final answer, the value of c. But I mean, which now we can just take the derivative, right? Now we're going to take the derivative. So d over dx of 40c squared minus c to the 4, right? What is that? This is essentially just equal to 80c minus 4c cubed. Now we're going to set them equal, right? Set them equal to 0. So 80c minus 4c cubed is equal to, this is equal to 4c times 20 minus c squared, which this one is equal to 0. So this gives us 3 solutions, right? C equals 0, C equals 20, and C equals 2 root 5, and C equal to negative 2 root 5. But now we can see that the first answer and the third answer are both like nonsense, because we need C to be positive. Wait, actually not necessarily, but yeah. So 2 square root of 5 and negative 2 square root of 5 should be the same because of symmetry. Yeah, so wait. Yeah, so we have these three values. But 0 is obviously not necessarily the case, right? Also, actually, we're just going to do the second derivative test. So d square over dx square of what? Of 40c square minus c4. Wait, actually, d square with dc square. Sorry, the variable is c here. Oh, this one is just equal to ac. This one just equal to 80 minus 12c squared. Which basically means that if c is greater, if c is so if c squared is greater than 20 over 3, then we're going to get maximum. Since if the second derivative is negative, then we're going to have the critical point to be the maximum. So c squared is greater than 20 over 3. And obviously, c squared is equal to 20, which is obviously greater than 20 over 3. So therefore, the critical point to 5 is the maximum. So approximate 2 square root of 5 gives like 20. Yeah, so it's just 4.5, and that is our answer. Thank you for watching. Hope you enjoyed this, and I'll catch you in the next video.